After laying, the cables were attached to previously positioned metal spacer strips. Pre-punched tabs in the spacer strips being lightly hammered around the cables. Later, to prevent movement of the mats during subsequent road laying operations, the strips were secured to the concrete road base by means of high tensile steel pins, fired into the concrete by a cartridge-operated tool. At intervals, moisture and snow detectors were included in the circuit. The control cables for the detectors, together with the heating mat coal tails, being routed back to the supply point. The cable laying was quickly followed by the application of a sand asphalt protective layer. This section of the road complex is on solid ground with no waterproof membrane. Following normal procedure, the sand asphalt was laid directly over the cables, being raked to a nominal depth of 23 millimeters. This was compressed by a conventional road roller to a depth of 16 millimeters. Mineral insulated cable, being robust, is completely unaffected by the heat of the asphalt and the weight of the road roller. In London, with its continuous high-density traffic, normal road surfacing materials are unsuitable for use as the final carpet, and so a hard-wearing mastic is laid. Road-making machines cannot cope with this mastic, and hand-laying was necessary. Granite chips were incorporated in the wearing carpets, and the mastic compressed with the standard road roller. As soon as the final wearing carpet had gone down on this section of the road complex, the slip road from Blackfriars Bridge to the Victoria Embankment, it was open to the public, to ease some of the traffic congestion that had become a familiar pattern at this important road junction. And the work of laying the heating cables on the underpass was started without delay. Here is a view of the M1 motorway, the backbone of Britain's new super road system. The motorway links London, the capital city, with the industrial north. Crossing the Don Valley at Tinsley near Sheffield on a two-tier viaduct over 2 kilometers in length, seen here under construction. The viaduct passes close to the Blackburn Meadows power station and is exposed not only to the elements but also to the condensate from the power station cooling towers. In adverse weather, ice could easily form on this 6-lane highway, so creating conditions extremely hazardous to the fast motorway traffic. It was decided that this important section of the M1 should be protected by means of road heating. An electrical system at mains voltage was chosen, and as in the case of Blackfriars, BICC mineral insulated heating cables were specified for this, one of the largest installations of its type in the world. For this contract, over 1,500 heating units were supplied, with a total loading of 4.8 megawatts, and these were delivered to site in coils. To facilitate handling the coils, the contract electricians fabricated on site a simple payoff reel, which was used with a laying jig designed by BICC, and this resulted in an improved laying technique. The jig consists of a lightweight former, fully adjustable to allow for variation in mat sizes. The heating cable was drawn off the payoff reel and tensioned around the end plates of the former in a configuration of 8, the layers being built up until the whole of the heating unit was accommodated on the jig. In this way, loading the jig became a simple and speedy operation. The jig, fully loaded, was carried on to the laying site and inverted. The leading end of the cable was released and laying started. The electricians discharged a loop of cable at each end of the jig alternately, and because of the configuration of 8, each run fell naturally into position as the mat was built up. Using this method, a small team of electricians was able to charge the jig and lay a mat in a remarkably short space of time. The cables were laid on metal spacer strips, the pre-punched metal tabs being hammered around the cables in the normal way. On this elevated roadway, cold tails were not required, as the connections to the feed cables were to be made within specially designed junction boxes situated on the underside of the bridge structure. Snow and moisture detectors were placed at intervals along the structure, being positioned outside the crash barrier for optimum performance. Normally, when the heating mats have been laid, they are covered with a sand asphalt protective layer, but here the technique was slightly different. The heating units were incorporated in the waterproof membrane, so obviating the need for a protective sand asphalt layer. The waterproof membrane was laid to a depth of 65 millimeters and troweled to a smooth finish. Finally, the wearing carpet was laid using a standard heavy road-making machine. The carpet consists of 50 millimeters of sand asphalt with a 15 millimeter granite aggregate. It might be argued that in Great Britain, with our temperate climate, road heating is a luxury. But with more than one vehicle to every 10 meters of roadway, we have the highest density of traffic in the world. The cost of a road heating installation constitutes an insurance against loss of life, injury, and damage to property, and the chaos that can arise when inclined and elevated highways are rendered hazardous by ice. There is no doubt that road heating is making a valuable contribution to safety on the roads. The Blackfriars Road Complex in London and the Tinsley Viaduct near Sheffield are but two of the many highways installed with BICC mineral insulated road heating cables, both in the United Kingdom and on the continent. And whatever the weather, the authorities and the motorists will have the satisfaction of knowing that these highways will be iceless highways.